Okay, thought I'd do a couple of double integration problems. So I'm going to do one over rectangular regions and then I'll do one over more general regions as well. So with rectangular regions, we're given the terminals. So this is over the rectangle of x going between 2 to 3. So x probably, like through here. And y going from 1 to 5. So 1. So we're looking at the integral of this function over this region here, if that's x, that's y. Now, as I approach this, I note that first I need to deal with this x e to the y x, where x, with respect to x. Now, I can do that, and I think we did it in today's lecture, and it gives us something like, I think it's e to the x minus 1 times e to the x or something. But probably what's easier here is if I change the order of integration and integrate with respect to y first. Because we'll see what happens if I integrate with respect to y first. I just need to be careful of my terminals. So this will give me here, instead, x on the outside, y on the inside, so these swap around, and I get x e to the yx dy dx, which now gives me, leave the x terminals on the outside, integrating with respect to y and fixing x as a constant just becomes e to the yx between the values of y 1 to 5, and then all of this dx. Now, it comes from the integration rule. If I derive e to the kx, this gives me k e to the kx. So we see here, essentially, since we've got y's, this is why it returns to this way here. Or the integration rule then is e to the kx gives me e 1 over k e to the kx plus c dx. Okay, so let's keep on going. So this, still integrating, simplify the inside. So I'm going to have e to the 5x minus e to the x, y equals 1. In that case, with respect to x, both of these I know how to integrate nicely. So this will just give me e to the 5x on 5 minus e to the x on, just e to the x over the terminals 2 to 3. So substituting those values in, I get e to the 15 on 5 minus e to the 3, subtract e to the 10 on 5 minus e to the 2, like this. And I think I can probably just leave it in terms like that rather than any more simplification. Okay.